All right, welcome everybody, and good to see you here on this early morning. Before I get into my presentation, I actually wanted to seat this a little bit into a broader context. As Tom mentioned, I spent 7.5 years at VMware, and I joined VMware because I saw what I thought was a very interesting trend, which is this idea of abstracting compute could potentially change the world. And I remember in 2005, 2006, thinking about all the possibilities, that if we could abstract the underlying compute and create virtual machines, then suddenly we could dramatically drop the cost of compute, both managing it and deploying it, and that this would allow for almost infinite innovation. And to some extent, that was right, and to some extent, unfortunately, that was wrong, because I found myself in 2011 looking at the world going, wow, it's amazing how VMs have now taken over. However, simply abstracting compute doesn't truly bring down the full cost and bring up the agility of IT the way that many of us hoped that it would. And what I found in talking to customer after customer after customer, operator after operator, is that unfortunately there was a weak link. Yes, abstracting compute was pretty much there. The storage side, as we heard a little bit, is on its way. We can see it. But unfortunately, networking is holding back the software-defined data center. And so, since I helped coin the term the software-defined data center, I'll go back to, I think that the primary idea behind the software-defined data center is that we want a fully automated IT. We want a fully automated IT by abstracting and pooling all the underlying resources so that we can automate them in a different way, one based around true artificial intelligence-based automation, not around a set of heuristics. And so, as I said, the challenge that we have right now is we're on that way in terms of compute and storage. But in networking, we're not there yet. You know, why is that? In some sense, I think we all know where we're moving. I think Andy did a great job of starting out talking about the principles of software-defined networking. And for the most part, everybody in the industry agrees that we need to have some level of abstraction of the network, that we need to have some level of separation of the intelligence from the underlying hardware, and a logical centralization of this networking intelligence, right? That is the whole idea of networking. And I think Martin Casado said it very well in his original PhD thesis when he said we need a separation between the data plane and the control plane. All right, so we're all good. If everybody agrees with that, why is it that we have right now this really interesting dynamic that's never been seen before, that I've seen at least in the IT industry? On one hand, 95% of people say we will adopt SDN by the end of next year. That seems amazing. On the other hand, if you look at how many people have actually adopted SDN, it's very, very low. So why do we have what seems like tremendous excitement and tremendous hype, and at the same time, it seems like a stall in the industry at the same time? The reason is that we don't have fundamental agreement in terms of how this is going to be done. In fact, we have a whole set of disagreements going on right now in the industry. Probably the biggest of which you started to get a sense of in listening to Mike Dworkin's presentation about 40 minutes ago, which is, while everybody agrees that some level of intelligence needs to be centralized, no one agrees as to how that should be centralized and how much that should be centralized. I like to describe this as, a fundamental disagreement in terms of how to manage armies. And so if you look up there on this slide, I have two kind of different models. One model I think a lot of us understand is this idea that you stand up, you have a set of generals who look at what's going on out there on all the battlefields, that have their set of assets, all of their soldiers, create battle plans, send out their armies, and really direct every step of the battle. Walk forward 100 steps, take out your gun, fire your gun, reload your gun, and move on, right? We've had some evolution, but this model still exists in the command and control armies of the world. What we've seen, though, in the military is there's a new model that has come up that is in many ways more effective for certain different kinds of conflicts, like we've seen in Afghanistan and in Iraq, which is this concept of saying, I've got special forces, I've got fewer of them, they're very, very highly trained, they have tremendous capability. What I do is I communicate to them the overall objective, but I communicate much more infrequently. I don't tell them how to do their job, I tell them their objective, and I assume that they can go out, and if I tell them their objective well enough, they can go out and figure out what to do next. There is a village. It is in the corner of Afghanistan. We have some insurgents there. Please go and form around that and then check back in. They go, they do that, they check in. We say, you know what, the insurgent is gone. Now there's a family of civilians. Please leave it alone. All right, great. Wait for next instructions. Why do I tell you this? Because this actually models very well what we're seeing right now in the networking industry. One group is saying centralize all of the intelligence in one place, in one central location. If you look at OpenFlow, what's going down there, that is really this view materialized in product of saying we really want to have, in a sense, the control plane in the data plane. At its extreme, the first packet of every flow needs to go through the controller to figure out where to route it. Now, obviously, there are gradations of that. I would argue that to some extent, some of the people who are doing the overlays and who strongly believe in overlays are also in this kind of view of the world. The controller needs to be not only a strong brain, but the primary brain of the entire system. On the other hand, you've got a set of people who say, no, that's the wrong way to run networks. Hardware is fundamentally better at doing a whole set of things. And in networking, performance and reliability, but especially performance, is key. We're seeing the amount of data flowing through our networks growing exponentially. Adding latency into the system is going the wrong direction. What we instead need, therefore, is the special forces model, the distributed model. Really high-end hardware that knows what to do very, very well. And then communicate down to that hardware, add intelligence, add programmability, but only where it is necessary. And so if you listened carefully, for example, to Mike Dworkin's presentation, read a lot of the blog posts that he and others have posted, it is a view of which what is really missing from the network right now is an ability to capture and understand the needs of applications and communicate those needs down to hardware that is incredibly capable. Which one of these two models is right? I'll tell you honestly, I don't know. I see arguments for both sides. I don't even know if what we'll see is one of the two models will win, or in fact that we will see coexistence. In terms of warfare today, what we see is that there's a need both for traditional armies as well as special forces. They accomplish different objectives and they're appropriate in different places. So it may be that we end up not having a choice between these two models of SDN, but in fact a cohabitation of two models where each makes sense. Regardless, I believe this is a critical debate that is happening in this industry. And it is great to see this debate because within the debate lies great innovation. People at least are rethinking how the network should be done. And I love the fact that inherent in both models is an idea that we need to have some level of abstracted centralized intelligence and we need a way to program the network. So let's celebrate that, but also recognize the impact of this. Today, what we have is far too many incompatible technologies. So if you ask yourself that question I asked earlier, which is, you've got 95% who say they're going to deploy SDN, but very few who actually have. Why is that? Well, one of them is that right now as an industry, we're asking people to bet their careers, to bet their money. And it's incredibly risky because it's unclear what's actually going to win. Controllers, do we need controls? Absolutely we need controls. Great, which one? There are 30 to 40 controllers out there in the world. For the most part, they all do roughly the same thing in slightly different ways. But for the most part, none of them work with each other. And so what happens when I go and I talk to end user after end user, they say to me, yes, I think I like the general visions, but I'm struggling to be able to make a decision with my dollars. I'm doing POCs, I'm kicking the tires, but I'm not yet quite ready to go that next step, unless I happen to be very, very deeply locked to one of the key thought-leading vendors out there. So I certainly talk to people who are all Cisco shops, and they're really thrilled the direction that Cisco's going, and they want to adopt that. I know people who are strong VMware shops, and they're thrilled with NSX and really want to adopt it. Unfortunately, I meet plenty of people who are both strong Cisco shops and strong VMware shops, and they're really struggling, let alone everybody else in the world that has a mix of a whole set of different things. And so the question that we have, we know the truth, yet we have these incompatible technologies, we have these wars, how are we going to overcome that? One option is that as an industry, we can pick a winner. And this may happen, right? If you look in the old days of virtualization, in many ways we all gained from the fact there was one winner, and it was VMware. And as a result, if you're a storage player or a management player, you can say, I'm going to be the best management of storage platform for VMware. And you got an entire industry, and you can see them all at VMworld, that did that. And yes, there's Hyper-V and Zen and KVM, but for the most part, the fact that we had a platform with 80-90% market share really did allow for great innovation in the space. And so one option we have right now is you can anoint a winner. If you're going to do that, my guess is the two leading candidates right now would probably be VMware NSX and Cisco, but there may be others. The good news in that would be very useful for our industry. I can tell you that whoever you anoint as the winner is going to be thrilled because there's billions of dollars in controlling that narrow waist that is SDN. Unfortunately, that is so attractive that you have everybody fighting to say, pick me, make me the key platform. Even tier 2 and tier 3 players who have no chance are still going out there and saying, I want to buy that lottery ticket because even if I have a 10% chance of being anointed the winner in the space, billions of dollars. Yet this is insanity. It's not working. We're not going to anoint a winner. There are too many powerful forces in networking. And so if we don't anoint one winner, how do we move forward? The answer that I will offer is I think we need a neutral playing field. We need something which is nobody's exact preferred perfect platform, but that everybody can live with, that everybody can build on top of. Who are you going to trust to do that? Pick the vendor? You know what? You're not going to pick any vendor. And so this is where I think that open source has a role to play. I'm not going to tell you that it has to be OpenDaylight, although right now if you go out and you read blogs and you look around, I think OpenDaylight is undeniably the leading candidate for this. What are we? We're an open source project that is attempting to create a platform that is that even playing field for everybody, that everybody can connect to, can build on top of. How do you know we're not out there to make all the money in the space? Well, we're a nonprofit, so there is no profit motive. It is simply a community of developers that is trying to bring all of these different competitors in the space to work with each other to build that platform. You may immediately think this is really, really hard, and I will agree with you. So let me tell you a little bit about our project goals and where we're moving. Our project goals are actually relatively simple. I started by saying what is stopping us in SDN is right now these fundamental disagreements that exist that are leading to so many duplicative, incompatible technologies. You could think that simply going to something like the IETF or the ONF could solve it, that we could sit there and throw PowerPoints at each other, and at some point someone's going to go, oh my gosh, my PowerPoint's completely wrong, yours is completely right. Great. I would argue that in general, standards work very well for simple systems. They work very poorly for complex systems, and what we have here is a complex system. So OpenDaylight's project goal is to internalize all of the key debates within the networking industry, specifically around SDN and NFV, but to internalize them not via PowerPoint, but to internalize them with code being the primary weapon or area of agreement of choice. Dave Meyer, who's sitting over here, coined the term, code is the coin of the realm, and I think that describes it very well. People are showing up, and yes, they have disagreements, but the way that they're proceeding with these disagreements is with code. Mike Dvorkin, who was here earlier, believes strongly that we need application policy, and the way he's doing it is he's convinced his employer to let him grab a whole bunch of engineers, and they're creating a set of code that they're contributing to OpenDaylight as a way to convince the industry that this is the right way of doing things. And so if code is the method, what we're trying to do is to get broad acceptance of this code, to get people to build their products on top of it. And the way that you do that is you build a true community. Another thing that is often said, and Dave, I don't know whether to attribute this to you or to somebody else, you can nod if it's to you, but one of the principles in a project like ours is you leave your badge at the door. Once you walk in, so was that yours, Dave, or is that somebody? Yes, it was? All right, great. You'll hear from him later. This idea that we're first and foremost a community of smart people. Yes, we have disagreements. Yes, people pay our salaries and we have to remember our corporation's strategic goals. But for the most part, when we're in a room, we're just a bunch of smart people trying to solve a problem together. Have we been able to get the biggest players in the industry on? The answer is yes. As you can see from this chart today, we have people putting their money where their mouth is, putting their developers where their mouth is. We've got roughly this year we'll get between $80 and $85 million worth of investment from the industry into this project. Think about that as a startup. If a startup wanted to go in and every year put in 80, 85, growing at close to 100% rate, the amount of funding that they would need, possible but very hard to do. And then get everybody to accept that they are the platform. Yet we're doing that. Most of those investments are actual developers, they're people. People writing code, doing documentation, doing testing. On the other hand, now, all right, great, you see some big vendors out there. What about the startups? Every month, more startups join. So today, we're a community of north of 40 different companies, but really we're a community of 185 developers as of yesterday who've contributed to it, and a broader community of 500-600 people who really care, who are participating around this project. Now, why? Why does this matter? If we succeed, and I certainly believe that we will, we are creating a broad SDN code base that anybody can use, that anybody can contribute to. People often ask me, how will it be consumed? Will I buy a solution where the OpenDaylight code will, in a sense, have been OEM'd into the heart of that solution, or will I deploy it as its own solution? And my answer is yes. There are many models. It'll be consumed in many different ways. What we're trying to do is avoid that duplication. Let's stop reinventing the wheel that is non-differentiating. Let's have the industry focus on the stuff that is differentiated. The hardware on the bottom, the applications on top, and the management on the side. That narrow waist should be a platform. It should be owned by no one. How are we doing in terms of momentum? Amazing. You're seeing commits per month that have, with a project that has less than a year, that is up in the stratosphere among the top projects out there. Don't trust me, look at us compared to other projects out there, looking very, very similar to the trajectory that OpenStack took in its early days. And again, even if you just simply don't look at us as an early day, but just as it is today, what you find is that our commits are among the top ends of all the major open source. It is true that we're primarily known in the networking industry. This is a little harder for people to understand than things like Hadoop or MySQL. But you see, we compare very favorably. You're going to get these slides in the end, and I did a longer version of this at Interop for those who are interested, but I just want to fly through some of the slides that you will see. At the heart of the OpenDaylight project is a controller, but we're far more than a controller. It begins with a controller, but really what we're building is all the sets of code, all the sets of functionality that you need for an SDN and an NFV solution. It isn't dominated by one vendor. This was our last release that just came out in February. You see that we had many projects beyond the core controller, and if you look on the right side of that, what you're seeing is many different corporations submitting projects, driving these projects, and it's very exciting to see true collaboration between individuals who work for companies who are bitter competitors. From an architecture, again, one of the key things for us you'll see on this slide is there is a core controller, there's a set of functionality, but there is one key thing that we do differently than almost everybody else out there. Where most people are picking a set of winners, a set of friends, at every level, whether they be southbound protocols, northbound protocols, services, overlay or non-overlay. As I said, we are internalizing all of the key debates that are happening within this industry. And as a result, we recognize that we are in a mode of brainstorming, of hyper-innovation right now. And therefore, we've built it to the heart of our platform, something called the service abstraction layer. The service abstraction layer is just that. It is a layer that allows us to be able to say, define your needs, define what actions you want the network to take, and actually auto-generate code that is then able to work with a variety of southbound protocols, and therefore with a variety of hardware. Our attempt right now is to build a very broad tent. that allows and supports all the different views and all the different technologies that are out there. Now you may ask, is that the right long-term architecture? Do we really want 18 southbound protocols? Probably not. But unless you can all agree together of which ones are going to be the winner, this is a necessary stage in the evolution. Because it is far better to internalize the debate than to have the debate happen in a way with proprietary code that nobody can look at outside between competitors screaming at each other. Why should you care? As OpenDaylight becomes more and more adopted, more and more successful, you're seeing greater interoperability in the space already. You're seeing greater innovation. It's easier for a startup to come in because they don't have to invent the entire stack. They can take whole pieces, wholesale, or simply plug into it. For end customers, less vendor lock-in, easier ability to switch in the future if you need to. And as analysts are saying, people believe that you're going to end up getting basically two styles of controls, those based on OpenDaylight and those that aren't. The last one I want to offer, and I'm just running out of time, is that there is immediate value. It's not just something to be excited for in terms of the long-term potential of this project. There are a lot of people, as I said right now, who are in the middle of doing evaluations, POCs, of SDN technologies. If you don't use OpenDaylight, you find yourself having to do 15 POCs to, you want to look at overlays, pick one. Well, actually, you're going to have to pick 5 of them, and they're all hard to do. So OpenDaylight's a great way, and we're seeing people do that, to educate themselves, to test multiple SDN approaches, and then to go down the solution selection. Here I've got a few lists of resources if you found yourself intrigued by this. Look forward to communicating on Twitter with as many of you as use that.